check 1 2. Why is it that every time sounds a bit different? Maybe not every time. Maybe every time. 1 2 1 2 1 2. Mic check. Oh yeah. What's going on here? It's still on. No. Yeah, I do remember it's like a shit ton of to do. And I've introduced nil. Brilliant. Just brilliant. Not necessary. That can be figured out later. Later? What am I doing? Okay. 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 Gotta try and figure out where I am. Excuse me. What is this again? Ah, yeah. And I think I still haven't tested any of the methods. I'm thinking I should just support parsing expressions. Maybe not yet. Tokens have been advanced. Yeah, we're at this. Note how the protocol for our parsing function plays out here. Starts with the current token of the prefix and it returns the current token being the operand of the prefix expression. Operand of the prefix. Yeah, which is the integer or the variable, which is the last token of the expression. Right, yeah. The tokens get advanced just enough. The neat thing is how few lines of code are needed for this. We didn't, for argument's sake, use this recursion. How would this work? You'd have to keep parsing till you reach the end of the statement, expression, statement. maybe. Yep. Precedence and parse expression is used. Now we're gonna parse infix expression. Guess it's the same test. As with prefix operator expressions, we can use any expression to the left and right of the operator. Not equal to, equal to. Okay. Because of the two operands, left and right, these expressions are sometimes called binary expressions. Whereas the prefix expression will be called unary expressions. Unary. Even though we can use any expressions on either side of the operator, you're going to start by writing a test that only uses integer literals as operands. Excuse me. As soon as we can get the test to pass, we'll extend it to incorporate more operand types. Thing kind of makes sense to include expression statement. Why is the test chat still there? Can I delete it? Ah, fuck it. Can't be bothered. Yeah, infix. Yeah. Totally zoned out for a second there. Thinking about the cheetah and the gazelle. Okay. Expression statements. Yes or no? Actually, I think no. I can still pass them as let statements. Okay. So I would say I'd have to go back. Yeah. I can use okay. I guess we're doing this. Test prefix. Yeah. Prefix operate prefix expression parsing. Okay, so let's have a few inputs. We'll go let x equals -5. And then we'll go let semicolon there. And y equals not was well, yeah, do not 5. Oh, tests. Sorry, input. Okay, what do we next? I need the lexer. Lexer dot new. Yeah. Can use testing dot allocator. And then we need input. Brilliant. And then we need parser. It's going to be new and lexer. Okay. Okay, then the first thing we need to do is p dot re. No, it's a d init. What did I call it? Yeah, it is free. That's strange. Then allocator destroy. What is testing? Destroy t first, and then do L. Okay. We need to get program. Okay. Parse program. Okay, yeah. That program parser dot error count 0. Program that's statements, I think. Yep. Guess we go through for program dot statements. Keep the index. Yeah, why not? Statement comma I think I had test let statement. I did. I think I'm gonna do expected value as well. For now, yeah, we'll just check. Perfect. I want to check if it's let statement has token name and value, which is an expression. Okay. Testing dot expect equal strings statement dot let statement dot value dot literal comma expected value. Should be a few errors. Yeah. So okay, I know. I can make this nullable. Then if expected value, I'll just call it B. Okay. That should be fine. So if I go copy these over, makes my life a bit easier. And then expected value would be another const u8. Expected value is -5. Not 5. Okay, expected name tests by node expected value. Okay, see what happens. Take test source parser. Beautiful. Okay, I gotta pass null. Oh, it's not. Expression. Ooh. What's that? Expected type. Expression union. Oh, really? Unreachable. Interesting. Should have been a prefix expression. Interesting. Yeah. What's this? Oh, hang on. I think I'm not handling some of the errors. Yeah, I think this can error, yeah. Okay, just that one. Dot tag type found null. Okay, nice. So that means the test is working. And the problem is with prefix parse functions. Parse program, yep. Statement is parse statement. So parse statements return, okay, here. Don't handle yeah. Later. So I need to okay. Some shit in my eye. Still there. Okay. Yep. So I need to handle prefix. Identifier integer prefix expression. Do I go by token type? I would guess so. Ah, fuck, yeah, okay. Expression statement. Oh no, actually, yeah, I can just extend parselet statement. So it does identifier. Oh, here, there we go. Interesting. I forgot about this. Expression parsing. I think I could just call parse expression. Takes a parser. Yeah. Okay, I think that could work. So we don't need this while. Let statement dot token name value. Value is equal to self dot parse expression. Okay. So that means in my test I made a mistake. Test let statement. Name, okay, it's name dot value. Okay, yeah, no, that's fine. Okay, let's see what happens here. Missing struct field. Hang on. What did I just do? Parse let statement. Hang on. Yeah, that was the identifier. Let statement dot value is equal to self dot parse expression. Excuse me. Does expect peak register errors? Yeah, it does. Guess in that case I can just make it, just return what I have. let statement, and then guess I can remove. No, I can't, because return can still return null. Okay. Okay, what does that look like? Still fucking null. SAST dot expression. Interesting. Am I not returning the parse prefix? Yeah. I guess. I think I see the problem. I'm passing a pointer, but I haven't allocated it. So as soon as it goes out of the scope, yep. That's expression, and then that means I gotta keep track of all the expressions. Hmm. It might be was prefix. Yeah. Happens if I do this. And how can I make this work? Ooh, it's fun. It still needs to be a pointer. Let's have a look. Say, yeah. Let's go to the latest. And what I'm looking for is struct. Guess we're going top down. About the order and size. ABI aligned. Here comes the cat. Point vec. Packed, packed, packed. Annihilation will be unavoidable. Every broken enemy will know that their opponent had to be invincible. Okay, fuck it. I think I'm gonna add to expression. Gonna be a pointer. And then I can just keep track of the allocations. Okay. So prefix expression is going to be self dot allocator dot create st dot prefix expression. And then gotta free this at some point. Yeah, I'll keep it simple. But now, things to free. Gonna be a slice of yeah. Let's say we have about 100 things. What type of things? Interesting. Can you have... Why did I think there wasn't any type? Primitive types. The type of types. Not confusing at all. The type of types. Hmm. Can I just do any opaque? Then, because I don't care about the type. Where is it? Free. For self dot things to free thing dot allocator dot destroy thing. Oh, it's not allowed. Okay, well, I tried. Can it just be... Well, I mean, one way to find out. Look away. Avert your eyes. What happened? Something blew up. It's gotta be comp type. Well, it's not comp time. I know. They can be ast dot expression. Can they? I guess they can. Interesting. Parse prefix. Can do is I can create expression. Then I do expression dot Yeah, just return expression. Don't know, feels kind of scuffed. Probably is. Does it work? Nice. So new. Thanks to 3 equal to undefined. Oh, do I need to like keep track of? No, I don't. Interesting. Yeah, I mean, it's a future me problem. Not something I need to worry about now. Just let the future me know that I'm just as surprised as he is. What am I doing? Yeah. Okay, self dot links to 3 of to 3 and -1 false expression. Don't try this at home. Motherfucker. So I didn't really solve anything, did I? Oh, okay, there is an error. No, I didn't switch to Zig. I think I was always writing in Zig. Yeah. Yeah, I think it's been Zig from the beginning. Hello, Commander. No, I think in the book it is Go. But I've been writing it in Zig. Some pretty devastating code, if I'm honest. I didn't really fix the problem. What's that, Commander? Yeah, I mean, I Go, I think it's kind of boring. Yeah, because I mean, it's not boring, like it's just for the first time when I wrote the interpreter, I did write it in Go. It made it simple. So I could focus on how the interpreter works and not worry about, like right now, up to like, you know, I don't know. Like Zig doesn't have interfaces, etc. So yeah. But yeah, it's interesting. The funny thing is, when I was writing it in Go, I was thinking of having my own garbage collector. And then I was like, I don't know, probably got lazy. I wrote it in C++ from the get-go. I used shared pointer first for memory management. That meant I have memory leaks. Yeah, I think it's fine. I mean, it's not going to be in production, so I don't really worry about it too much. Oh, okay. I haven't used C++, so I'm guessing. Okay. So you're saying garbage collector is fun. Mark and sweep. What is mark and sweep? It's called online one. I don't know what you mean. What's called online one? I implemented a simple mark and sweep tracing garbage collection. Oh, you track. Is this like kind of lifetime? So once something is no longer referenced, you can get rid of it. Okay. Some variant of tricolor marking abstraction. Mark and sweep often do not make the abstraction explicit. 3 sets are created: white, gray, and black. The condemned set. Okay. Black sets, the objects have no outgoing reference. A, F, B, C, D, A, F, B, C, D. Oh, okay, so it's kind of maybe. In general, GCs is about that. Okay. If something is no longer referenced, can delete it, yeah. But there is no lifetime here. Just traces reachability from roots. Gray set contains all objects reachable from the root, but yet to be scanned for reference to white objects. What was white again? Mark and sweep. I mean, it does look interesting. Excuse me. Weak collections. Yeah. This is a good idea. My ultimate plan is to make that again, but in my compiler by myself in LLVM. Nice. Make that again, but in my compiler. Okay. So right now, okay, it's only at the interpreter. It's a hard word to say. Interpreter. Now the question is, can this be a pointer? Well, we'll have to find out. Okay. The interpreter is like 50 times easier. Okay. I will be doing the compiler after I finish parsing. I won't do evaluation. Why is it still null? Access to union field pointer while union is active. Okay, just gonna undo this for now, because it feels pretty terrible. Okay, if I go back, should be null. To be honest, about 75% of why I wanted to show my interpreter. Oh, okay. No, I believe you. Do you have like a GitHub or something that I could look at? Yeah, you can just leave the GitHub link. Yeah, just give me a second. Don't need this. Yeah, don't need that. And then I think this definitely won't work. I just wanna, okay, yeah. All right, let's have a look at your interpreter. What is this? If you know, you know. Well, I don't. What test? I like your documentation. GC. Fair C++, so don't know how much of it I will get. been like so long since I read C++. Well, no, that's not true. I read it 2 weeks ago. I don't think I've ever written C++. Add roots. Oops, why did it select all? What's wrong with GitHub? What is scope? Oh. So scope. Ah, interesting. I wonder when do you decide to sweep? It's in internals. Okay, yeah. Collect garbage. Excuse me. I want to see, like, how do you decide something is gray? What was the colors again? White, gray, and black. Okay, so I'm guessing initially everything is white. Checks are the candidates for no. Is it contains objects reachable from the roots? Not sure I understand the technique. I guess everything would be marked white, right? Because at some point you will have to clear it. What was gray again? Objects reachable from the root but not yet scanned for references. Since they are known to be reachable from the roots, they cannot be garbage collected and will end up in black set after scanned. What was black again? Ensure to have no outgoing references. No candidates for collection. Interesting. I'll be honest, most of it is going over my head. Return lock. Set phase. What is a phase? You mean the language? Okay, interesting. The read phase and the run phase. Maybe some other phase. Okay. Read or run? It was important because I allocated things on reading. You allocated things when you read them. You mean the first scan, sort of? I allocated things on reading. Oh, okay. Gotcha. And I did notice something. Walk. Couldn't get walk. Real text removed. So while passing the code, I already had values. You mean it was allocated during passing? Parsing. Interesting. Language code is also a valid value in the language, and you can manipulate those. Sorry. The language code is also a valid value in the language. It's kind of like meta programming. You're writing the program that was also writing the program. Okay. Yeah, I've heard about it. Never used Lisp. What else is here? Parser. Yeah, that'd be cool. I'd like to look at your parser. It's actually not as good as... Okay. Yeah. I mean, yeah. I mean, the people who talk about it love it, and the others probably don't know about it. Yeah, I haven't tried it myself. Interesting. Okay. Yeah, I saw it in your documentation. Read list, read proper. Hey, your parser is kind of really tiny. Nice. Well, I guess that's the beauty of recursive descent parsing. To check parser. Just test. Okay. Close. Well, these tests. Okay, there's actually two. Parser. I needed to rewrite. Oh, you mean the tests? Okay. Internals. Tokenizer is tiny. Just a header file. Tokenizer. Yep. It looks pretty good, Commander. I think you've done a good job. What's internals? Oh, there's a lot more stuff here. Although I don't understand all of it, but looks like a lot of work. Nicely done. All the main functions are in built-ins. Yeah, I can see eval. And define set print debug. Yes, this is something I haven't done. What's a lambda? I was especially proud of the fact that eval is also a built-in. So my REPL is implemented in terms of the language. Okay, nice. Lambda is a lambda function. If you look at init, this defines new functions and runs the REPL. Okay. Oh, lambda. Oh, okay. You call print debug with the result of eval. Yeah. Yeah. Okay, looks pretty good. I think defines few functions and runs REPL. Pretty good. Okay, I got a bit distracted. I got to get back to my fumble. Okay. I'm not sure why it's... Hey, thank you for sharing your work. It's pretty good to see. Maybe it'll be a good reference. I want to like build a GC. Expected expression but found null. It was nice to show someone both one who understand what it's about and two, not a professional compiler dev with 2000 years of experience. Okay, fair. Yeah, I guess it is, yeah. Especially since you put a lot of work into it. I mean, I would say the guy who wrote this book is kind of like you. I don't think he's a professional, but he does understand it at a deep level. Okay, you know what? I think this is future me. Fix this. Expressions. No. What am I passing? Not in minus. I do think I have register prefix. What time zone? Bangkok, Thailand. Yeah, it's early. It's 6:30. Yeah, 6:30 a.m. Yeah, I only have time in the morning because usually during the day we work. Like I'm quite busy. I guess it's quite late for you. Because yesterday, we were talking about going to bed, so. I'm in Estonia. It's past 2. Yeah, it's quite late. I'm from Russia myself. Hey, I have a lot of Russian friends. There's a few Russians in my gym, and then I play badminton with a few of them. There's a lot of Russians here too. Yeah, I've heard. Yeah, I think most of the people here who I talk to, they say the same thing. Yeah, actually, quite a lot of them here. I know at least like 6 or 7 of them, but there's a lot more. Yeah, there is. So funnily enough, I know quite a few Ukrainians too. Yeah, also in the same gym, and yeah, that is. I don't think it's quite the coincidence. Wonder why. Yeah, I know it was a joke. Yeah, it's quite. I mean, diverse here. I would say it's people from all over. Okay, I'm too lazy to find out why my expression is now. Shit ton of ass. Yeah, like it's a good way to look at it. I suppose. I mean, it is that. No planets, maybe asteroids. Found no. Ah, fuck it. I think future me will figure this out. Probably, because it's going out of scope. Most likely going. Ah, I know why. Because. Yeah, I gotta allocate this memory to have pointer available outside. Okay, yeah, this is future me problem. Hey, Commander, thanks for hanging out. I think I'm gonna call it a day. I'm totally distracted now, and also a bit lazy, to be honest. All right, you get some rest. No, it was fine. I was distracted before I even started. But I was like, okay, I'll do a little bit. So yeah, it's okay. Don't worry about it. I don't think it was you. Okay, get some rest, Commander. I shall see you tomorrow if you're here. You have a good day. See ya.